This is a short section on how do we solve polynomial inequalities. So we'll just start off with an example, and I'll kind of walk you through the process about how to solve one of these. So for instance, solve this polynomial inequality. X minus 4 times x plus 3 quantity squared is less than 0. So what is one way to think about what that's asking? Well, on the left side is the polynomial, and what we're asking is for what x values is this function, this polynomial in this case, and that inequality is to asking me or telling me to just look strictly below the x-axis. In other words, where is the graph of the function on the left? Where is it below the x-axis in this question? So if you had a way to graph that thing in green on the left, then that might be pretty easy to answer just by looking at a picture. But what I'll show you is how do you do this just by using algebra. And so I've tried to break this down into about 5 steps that you could try to follow in order to solve one of these. First thing you should always try to do is get 0 on a side of the inequality. If you look at the inequality we're given, it's already done for you, so that's pretty cool. The second step is to try to factor whatever polynomial that you have. Again though, look at the polynomial you're given on the left, it's already factored, so that's done too. So let's get to the good stuff. The third thing you should do is find the zeros of that polynomial that's all factored, and then you're going to plot those on a number line. So there's my polynomial, and I'm just focusing on the left. I'm just going to find what are the zeros of the thing on the left. And so, well, x equals 4 is one, and x equals negative 3 is the other one. So what we'll do is we'll take those two values, x equals negative 3 and x equals 4. I'm going to say them that way left to right because I'm about to plot them on the number line from left to right. All right, so here's where we are so far. I've taken the number line and I've plotted these two special points on it. So what we're going to do now is, if I look at that number line, it looks like there are, in this case, 3 little subintervals that the zeros split the number line into. And so what we'll do is in each one of those subintervals, we'll pick any point that we want, and we'll call it a test point. And we'll plug it into our polynomial. And all we care about is, do I get a positive or a negative sign? So is it a positive or a negative number? So how I'll organize that is here. So in the red, the blue, and the pink, I've tried to emphasize that you've got 3 different subintervals. And so in each one of those, you're going to pick any point that you like. So I just chose negative 4 in the red interval, I chose 0 in the blue interval, and I chose 5 in the pink interval. You could choose whatever numbers you want in there. So what we'll do is we will take each of those test points, maybe one at a time, and you just plug them back in to your original polynomial, which is, don't worry about the inequality with the less than 0. I just care about the thing that was in green in the beginning. So x minus 4 times x plus 3 squared. So plug in each of those yellow numbers for the x's that you see in each case. I think I do this kind of all at once, but you could do these one at a time. So you could do the red interval first and then the blue, etc. But what do I want to say? When I plug in x equals negative 4 just to highlight here, well, I get this. And again, I'm just doing that here. I'll plug in 0 for this one and 5 for this one. So I'm doing all 3 of these kind of at once. You don't have to do them that way if you're not comfortable with that. So what do I care about though? So if I look here, where is this stuff coming from? Maybe what I see is, I see that this would be a negative number, that's negative 8, and then, well, you're squaring this stuff, so it's always positive. So what do you care about? What can you get away with here? All you should write down really is you just get a negative times a positive in this case. In this case, that's a negative number, that's why I wrote a minus sign there. And this is again a positive number, so I wrote a plus sign there. And then last but not least, this is a positive number, and this is always a positive number. That's why I've got 2 positives here. Again, I don't care about actually what number it is. I don't care what actual number it is what I mean to say there. I just care about what sign do I get. So when you do a negative times a positive, you'd get a negative, you'd get another negative here, and then finally a positive times a positive is a positive. So I wrote those in orange. We're going to keep track of those. That's step 4. So the last step, use the signs that you obtained above, in this case in orange right above, to determine which intervals satisfy the inequality you're asked to solve. So the original inequality was this one. Now what we're going to do is we're finally going to use that less than 0. What's that telling me about? Well, that's telling me that I want the negative signs that I just found in step 4. And the other thing that we're going to do is we're going to use parentheses in our interval notation because it's a strict inequality. It's just less than. It's not an or equal to. So what I'm going to do then is I'm just going to copy paste what I got above where I put the signs that I found as they correspond to each subinterval that I had. So what do we have then? Well, this red interval got a minus and this middle blue interval got a minus. So the red and the blue interval should be the answer to this inequality that we're asked to solve. And so in this case, we're going to say the red interval is minus infinity to minus 3, not including negative 3 again, because remember, at negative 3 is when we're equal to 0, but this says I don't want to actually be 0. Remember that. And then, so there's a little break there at negative 3, so I've got this union, and then the next interval in blue is from minus 3 to 4. And that's the answer to this one. Let's try and do another example really quickly here. You notice maybe what's different. It's a little bit longer as far as factors go, and also I've got a greater than or equal to in this case. Really just the main thing you care about is the or equal to. How you could think of this again is what we're asking with this inequality is when is the graph of this, this piece says above or on. So above or on, and the or on comes from the or equal to, above or on the x-axis. So how do we do this with algebra though? Get 0 on a side, all done. Step 2, factor your polynomial, all done again, that's great. Step 3, find the zeros, plot them on a number line. So write down your polynomial that's on the left in this case. You see the zeros are negative 1, 2, and 3. So plot those on a number line. And in this case, you see that there are 4 subintervals. On to step 4, pick test points in each one of those subintervals. Again, to figure out the sign of your polynomial, which is in green above here. I guess I just highlighted that in red, didn't I? To figure out the sign of that thing in each one of these subintervals. And so, okay, I just copy pasted my number line. I'm telling you what test points that I decided to pick. You don't have to pick the same ones I did. Just pick any point in that red interval. Pick any point in that blue interval, and so on. And what we'll do is we'll plug those in again to your polynomial that I'm highlighting up here in red. Plug those in for x and see what kind of number you get, positive or negative. So I organized that information over here in a table because it was a little bit more convenient for me, rather than trying to fit them in with the number line like in the previous example. But what am I trying to say here? When you take negative 2 and you plug it in for all these x's that you get, you'd get that negative, negative, positive, negative. That's 3 negatives, means you got a negative left over, so you get a minus there. So I hope that that makes sense how that little table is working. What we're going to do is we're just going to transfer this minus sign, I'm saying, goes with this interval. Similarly, this plus sign that came from the test point x equals 0, that means this blue interval gets a plus sign, and etc. So there are the signs of my polynomial in each one of these subintervals. Now we're on to step 5, where we look at the signs that we obtained above. We're going to use those to determine which subintervals satisfy the inequality. And in this case, ours was a greater than or equal to. That means I want a plus, and what we're going to use is brackets on the endpoints because it's an or equal to in this case. It's okay if we are 0, is what that says. So if I copy paste my answer from part 4, which was how did I determine what the signs were, if I want the pluses, then my answer should be this interval from here to here. And so how do I write that down? That would be the blue interval union the pink interval. And notice again how I've got brackets everywhere there. But last thing you might notice is that this simplifies a little bit. 2, there's no break there really, right? 2 is included in both of those. So it's kind of silly to have this break at 2 if it's in both. Therefore, we could just combine it into the singular interval from -1 to 3. And I'll circle that as my final answer.